In this video, we will explore listening to students and understanding their thinking in the context of fair sharing. Mrs. Kellogg, an elementary school teacher, is working with a small group of 3 students, Melanie, Matt, and Kyle. Throughout the video, we will draw your attention to some of the purposeful behaviors on the part of Mrs. Kellogg. We notice first that she is implementing the activity in a student-driven way. The strategies emerge from student thinking. The students create, compare, and justify their work, and the teacher engages the students in discussions of ideas. Periodically, you will see Mrs. Kellogg wait and listen. She allows students time to process and respond to questions and ideas posed by others, and listens carefully to the students' thoughts and language. Mrs. Kellogg also poses a series of questions to probe deeper into the students' reasoning and encourage them to justify their conclusions. Based on the student responses and the discussions that occur both between students and between the teacher and students, Mrs. Kellogg makes choices on how to modify her instruction as she goes. As the students discuss their thinking, it is important for both the teacher and the students to form the habit of making connections. These connections may be between multiple representations, they may be between 2 different student ideas, or between 2 different mathematical concepts. The session begins with Mrs. Kellogg introducing a fair sharing problem.
All right, thank you for being here this morning, and you're here to help me today solve some math problems. And this one right here is a math problem about pancakes, and we're going to read it together, and then you're going to have a chance to solve it and explain your answer to me. Mr. Tan took his students and their parents to a festive breakfast to celebrate the end of the year. 5 of the children ordered the chocolate chip special, which includes 8 chocolate chip pancakes to share equally among them. Mr. Tan asked them to tell him how they could find out how much of the pancakes each of them would receive. Now when you're solving this problem, you can use manipulatives. We have pretend pancakes here. You could use paper and pens to illustrate what you're thinking. It's your choice, and you can get started. I'm interested to see what you come up with.
We can write on this paper here, right?
Yes, you can. That's fine. What are you thinking, Matt? Tell me about your problem and your solution.
As I said, I divided the 8 pancakes by the 5 people and got the answer, 8/5. So then I simplified and made it a mixed number of 1 3/5.
Okay, can you illustrate this for me?
Yes.
Can you please explain your solution to me, Kyle?
I divided 8 by 5,
Okay.
and I got 1.6, so each student will get 1.6 pancakes.
Can you show me what 1.6 pancakes looks like?
It'd be, each student will get 1 full one, and then a 6 of another, and on a 6,
Can you write it out and show me?
like on a pancake.
I think it would help me understand what you're
So they
thinking.
get 1 full, so they get all of this, and then if you divide this
Who gets
up,
all of that?
one student gets 1 full pancake,
Can you show me
Yeah.
somehow that that belongs to one student?
student 1.
Okay, thanks. That helps me.
I spelled that well. And then a 6, and then 0.60 would be 60% of this one. So we're just a little bit over half of a pancake. So it's that long. So don't use that line. It's a little bit over half of a pancake. So you divide it. Oh wait, I'm doing it a different way. If you divide it into tenths, you get 6 of them. 4. This is bad, but let's say those are equal, so there are 10 of them.
Okay.
A student will get 6 of them, so you get 1, 2, 3, 4, 5, 6, and this could also be student 1. All of these is for student 1.
All right, you have to show me that all the students get the same.
And then another student 2 will get another full one,
Mm-hmm.
and then that again. So
While you're working on that, I'm going to go back to Matt and see what he's
Alright,
done
so
here.
I took my graph and I got student 1 and made sure that he had 1 3/5 of a pancake, and took student 2 and got 2/5 of that pancake, a whole, and then 1/5 of the next pancake, giving him 1 3/5.
But that's just one student, right? And there's 5 students total.
Yes,
So you
so I
need to show me
illustrated
that
2 of the
there's
students. Right then.
that this
So
is possible
student
for
3
all 5 students.
gets 4/5 of this pancake and 4/5 of the next one.
Okay, you work on that, and I'll come back to you in a minute. Melanie, can you explain your solution to me? I'm very interested in what you did.
So I knew that after hearing like what they were thinking, that like the 5 of the children had to split up the 8 pancakes. So
Okay.
I knew that each of them would get 1 full pancake,
And is that what you did here? 1, 2, 3,
Yes.
4, and 5?
like as people.
Okay.
But then I crossed it over like to down here so that like these 5 were like people and like because they would all get 1 full pancake. And then you have to, okay, there's 3/8 left. And so, or I guess 3 pancakes. So,
Is that what you showed me right here? These 3 are left? Okay.
so there's 3 pancakes left
Mhm.
and there's 5 people. So you have to divide it up, which I didn't actually get to that yet.
Okay, do you want me to give you some time so you can work on that a little bit?
Sure.
Okay. Okay, Matt, can you explain to me what you've done here?
Alright, so I kept on going and adding the students, so this one got 4/5 and 4/5, bringing to 1 3/5 again.
Mm-hmm.
And student 4 got 1/5, 1 whole, and 2/5, and student 5 got 1 3/5 on all of his. So if you bring it all together and take how much each person gets, then you eventually will get all of these divided equally, and all of the students getting the same amount.
Okay. Kyle, I would like to talk to you about your solution for a minute, and then I'm going to have you and Matt switch papers. And I want you to justify each other's work.
Well, I did student 1, he gets 1, and then his symbol is scribble, so I scribbled in 6 of his wedges, so he has 1 and 6 wedges of 10. And student 2 has 1, and he is just like kind of solid,
Mm-hmm.
and he has 6 wedges solid in. And then student 3, I have like colored in dots. He has 1 and 1, 2, 3, 4, 5, 6 wedges as well. And then student 4 is 1, and he has the lines. So he has 1, 2, 3, 4, 5, 6 right here.
Mm-hmm.
And then student 5 has open circles, and he has 4 here and 2 here.
Okay.
So each has a full pancake and 6 wedges to eat.
They're so creative. We're very creative.
So I had the 3 pancakes left, and I decided that I would divide them into 5ths because it would be easier since there was 5 people.
Mm-hmm.
So like down here, I like just like down there, I thought, well, each of them would definitely get like 1 like 5th, and so that would be.
I like the language that you're using, but I want you to think about whether these pieces you've actually drawn are
or 15ths.
1/5
Wait.
of the pancake. Because we're dealing with a circular object, which means
Yes.
these pieces.
So they would actually be like more like that,
Okay,
like that, but
good.
like that.
All right.
So like I guess if I had it like that, then so then okay, each would get 1/5 of each pancake,
Okay.
and then wait, that's not right.
Okay, so everyone gets one whole pancake,
Mhm.
and then there's 3 left over, and
Yeah.
you've drawn the 3 down here that are more representative of equal pieces. And then you cut them into fifths because there's how many children?
5.
5, yeah. And you explained to me that each one gets 1/5 of each of these pancakes.
Mhm.
So the question is, how much are they getting, is each child getting all together?
But then there would be some left of like the pancake.
Oh, why is this left?
Like, wait, I don't know. If I guess they would. Well, if there's 5 children, they would each get 1/5 of each pancake,
Right.
and
Okay.
then there's 3, so be 3/5.
Okay. That's great. You did a great job. So what is one person's share of the pancakes, Melanie?
They get 1 3/5 pancake.
Okay, great. Thank you.
So I see how you made it so that everyone got one whole
Yeah.
and then 3/5 in these other ones that are just left behind. I think it's a lot better than my method because, you know, you've got some people without a full pancake, so it just seems just weird.
Well, your current answer, 1.6, is like you're saying 1 6/10.
Yeah, and if you simplify
Which-
that, it's 3/5.
Yes, it's 1 3/5. So
Yes.
all the answers
but-
are.
I did sort of wonder why you, instead of using sixths on this, broke it into tenths.
Because I didn't want to break this into 6. I had to break it into tenths if I'm doing, because this is 6/10. So I'd have to break it into tenths and then give them 6 of it.
Meant
Mm.
fifths or tenths would work.
Yes.
Because
Yeah, I could break it into
Right.
fifths.
anyway, yeah.
So you kept with your decimal method?
Yes.
All right. For mine, I gave everyone the same amount, although just differently. I made sure that everyone got 1 3/5. Just I kept on adding other pancakes and just continuing on. Like if this one had 1/5, I continued on this one and a little bit on the next one.
Mm-hmm.
And then once I got to 3/5, I just went on to the next person and kept adding on and adding on and adding on.
I want you to talk about your answers and whether they're the same or not, and I want all of you to discuss how you would know whether they're the same or not. Okay?
We can figure out it's the same, because if you take 1.6 and you make it into a fraction, it'd be 1 6/10.
Okay.
Which
and then
simplifies.
when you simplify, you divide both by the same number. So if you divide them both by 2, you'll get 3 and 3/5, and then you have the 1 still.
1 3/5.
So
You agree, Melanie?
Yes,
Yes.
I do.
All right. How do you know that these are divisible by 2? Explain to me.
Because if you have an even number, you can always divide by 2.
I'll show you. So let's say you have this again, and so it's divided
Into fifths.
into fifths. So see here, you can easily make it tenths by just adding a line in the middle of each of these.
Because it's divisible by 2.
Melody, say that louder.
Because it's divisible by 2.
All right, here in front of you, you will see a solution to the problem that you just solved and discussed. And I want you to examine this solution and think about whether it is correct. Explain it to me.
No, you'd
Because
need
this is
half
incorrect.
another pancake to make this correct.
Because these aren't fifths. There's 5 wedges, but this is still part of the pancake, so it'd actually be 1/10 here, not a fifth.
Those are tenths, yes.
So it wouldn't be 1 1/2 and a fifth. Each has 1 1/2, but
It would be
they have 1
1/10.
1/2 and a tenth, not a fifth.
Yeah.
Which,
They're 1/5 of half, but they're not 1/5 of a whole.
yes.
Exactly.
If we say that this 1/5 is
Mhm.
actually 1/10,
Okay.
it would still be 1 plus 1/2 plus 1/10, which I know that is correct, like to our earlier answer, because if, like just to what we were doing earlier, 1/2, if you multiply these by the same, like by the same thing, number, I guess, which in my case, I want to get to tenths, because that's 1/10 and it'll make it easier. I know that 10 divided by 5 is 2. So then you would have to multiply 1 times 5, which is 5. And that would be 5/10. And 1 plus 5/10 plus 1/10 equals 1 6/10, which was Kyle's earlier answer, but in a decimal, 1.6, which also is equivalent to what me and Matt got as 1 3/5.